Number sequences, Year 7, Unit 7. Before we begin, it's important to learn some vocabulary for sequences. When we use that word sequences, we just mean a list of things that come in order. You might have talked about sequences in PE, a hop, a skip, a jump, a hop, a skip, a jump. In maths, usually sequences are a list of numbers, but not always. They could be a list of shapes. Here's some houses, and if we look carefully at the numbers on the houses, we'll see they make a sequence as well. These houses all are on one side of the road, and the numbers of the houses are 31, 33, 35, 37. That's a sequence. If we take any one of the numbers, then what we're looking at is a term in the sequence. A term means one of the numbers in the sequence. So 35, it's the number of the third house, and we call this the third term in the sequence. A sequence could go on forever and ever. In maths we call this an infinite sequence. Or it could have a limited number of terms. The houses in the street don't normally go on forever and ever. So, for example, there could be 20 houses in the street. This sequence would have 20 terms. How can we find a pattern that will work for any sequence? Well, it's quite easy to find a pattern to go from one number in the sequence to the next. Our sequence of house numbers, for example, had a adding to pattern. We call this the term-to-term rule. It's a way of going from one term to the next. And we could carry this term-to-term rule on quite easily. It can help us find the next few terms. So the fifth term is 39, the sixth term is 41, and so on. But what if I asked you to find the number on the 100th house in the street? It would take us a very long time to do this by adding on 2. We need a better way. We need a formula or a general rule to work out any term in the sequence. Sometimes in maths we call this a formula for the nth term, where n just stands for any place in the sequence. Let's see how we would do this with our example of house numbers. First of all, we look at the term-to-term rule. And remember, we spotted it was a +2 rule. So, if going from one term to the next, I actually add 2, what I'm doing is counting up in lots of 2. Or counting in 2s, we do that when we do the 2 times table. And it gives us a clue to the first part of our general rule. I've written it as a function machine because it's quite a good way to see how we find the pattern. We take the term in the sequence, I've written those in red, we put it into the function machine, and the first thing we do is multiply it by 2. What would happen if we did this to the first few numbers in our sequence? The first term was 1, the second term is 2, the third term is the third 3. So, if we multiply those by 2, will we get the house numbers? Well, no. We get 246. What would we have to do to make the 2 into a 31? We'd add 29 to it. Let's see if this works for the other numbers. What happens if we add 29 to 4? We get 33. We do the same to 6, and we also get... Just correct my mistake there and make it 35. So there's the terms of the sequence that we want. Let's remind ourselves how we got there. First of all, we multiplied by 2, and then we added 29. So if n stands for any number in the sequence, we multiply it by 2. We know how to write this. We write it as 2n, and then we add 29. So our general rule for finding any number in this sequence is 2n plus 29. Could we use this to find the 100th house number? Yes. N is 100, so 2 lots of n would make 200. Add 29, and we've got the number of the 100th house. It's 229.